warahmatullahi wabarakatuh. Salam sejahtera. So today I would like to discuss some of the tutorial question as per requested by some of you guys. So these notes I will put it in the Google site later on, and I will put it as under the summary lah, under summary file. Okay, question number 9. We start with question number 9. Hopefully I can cover most of the question. A car starts from a rest and accelerates uniformly for 20 seconds until its speed reach 10 meter per second. So it starts from rest, accelerate uniformly for 20 seconds, and its speed reach 10 meter per second. If then, okay, maybe I can try to highlight it straight away. Continue to travel at this constant speed of 10 meter per second for 100 seconds. Okay, and then finally the car slows steadily until it comes to rest after another 40 seconds. Sketch a speed versus time graph. So speed, basically you ignore the direction. So they want to do V against T graph. Find the acceleration of the car for each part of the journey. So acceleration for each part. Calculate the average speed of the car. So the last one, they ask you to calculate V average. Okay, you can start by trying to draw. Okay, you already highlight the important information. Then maybe you can try to draw the situation out. This is a car. Okay. Initially, it is at rest. Okay, and then accelerates for 20 seconds. So again, for the syllabus, A is constant. And then finally the speed over here, it reaches 10 meter per second. Then continues to travel at this constant speed for 100 seconds. So another 100 seconds it travels. Finally, the car slows steadily. I think I need to make this one a little bit smaller. Finally, the car slows steadily until it comes to rest for another 40 seconds. So the last part is 40 seconds. Oops. And finally, it reached 0 meter per second. Okay, so again, this is just a rough sketch, right? You can simplify this one because you basically want to draw inside a scale. So sorry, you want to draw it inside a graph. First thing first, you draw the axis. Okay, you use the correct units. You know that we are only discussing about the positive, so the V is in meter per second. If you can write this everything properly, then you might get 1 mark already. Okay, for the x-axis, you have to look at your scale over here. Okay, there's a key things. So initially the times is equals to 0. So this one, if I want to write in terms of timeline, this one will be 0. And then after 100 seconds, after 20 seconds, it reach 10 meter per second, and then it continues for 100 seconds. So that one already 120, because you add 100 with 20. And the last part is you add another 40, so that you get 160. Okay, so this is the numbers that you need to write inside your axis here. So roughly, if you can follow the scale, would be okay. If you not, then should be okay. And the last part is 160 seconds. Okay, and then it reached a speed of 10 meter per second. So the only y-axis, maybe you can label this one as 10. Okay, the next part is the easy part. Basically, once you have all these numbers, you just have to draw. So I just roughly draw the point here so that I can make my lines a little bit better. Okay, so it should look something like this. So basically, from 0 to 20, constant acceleration, accelerates until 10 meter per second, and then from 20 to 120 second, continues at the same velocity. It's still moving, but at the same velocity. And then from 120 to 160 second, the car decelerates and stop. Find the acceleration of the car for each part of the journey. So basically, you can divide into 3 parts. So B, can use when t is equals to 0 to 20 seconds. What happened with the acceleration? When t is 20 to 120 seconds, what happened to the acceleration? And when t is equals to 120, to 160, what happened to the acceleration? So you know that A is basically, okay, if you want to do it, I think it's better because you already have the graph, right? This is a graph of V against T. So if you want to find the acceleration, you can find the gradient of the graph. Okay, calculate the gradient so that you will get the acceleration. Obviously, you can substitute using V equals to U80 as well, so it's up to you. Over here, it would be 20, so it would be y2. Okay, maybe I write the formula over here. Y2 minus y1 over x2 over minus x1. So obviously you can write the formula over here, and over here. But since I'm running out of space, see, I'm running out of space, so I just wrote it once over there. So it will be 20 minus 0 over 10 minus 0. So this one will be 20 divided by 10, which is 2 meter per second square. Okay, again, this is a scalar, so you don't have to bother with the direction. Because we should bother with the acceleration, but we just leave it like that for now. A equals to, over here you can see clearly that it will be 0, but I just tried to calculate it to show it mathematically. So 10 minus 10 over 120 minus 20. So basically I'm taking out these 2 points. Okay, so this one becomes 0 because 10 minus 10 is 0. And then finally, this one would be 0 minus 10 divided by 160 minus 120. Okay, I think it would be 10 divided by 40, which is 0.25. Okay, obviously if the car, if it follows this diagram, so if we assume that it is moving to the right, so that means this acceleration is actually to the left, because of the negative sign. So before this, for this graph, you don't consider the direction because they ask you to draw the speed against time graph. But obviously, if you assume that it's moving to the right and you want to consider the vector as well, so this one is moving to the left, you can write it down, doesn't matter. So you can rewrite it. I think I'm going to show you to do it properly. A is equals to 0.25 to the left. Okay, this one A equals to 2 to the right. Okay, the middle one is acceleration is equals to 0, so you don't have to bother with that. Okay. Okay, question number C. Calculate the average speed of the car. So if you want to find the instantaneous, you can look over here. So you can find over here, over here, over here, over here lah. But if you want to find the average, basically you have to consider total, sorry, final minus initial, and then you just have to divide the time. I think I have to correct myself a little bit there. They ask you to calculate the average speed. So C, V average is actually equals to total displacement. This one is speed, right? Okay, kalau speed, total distance divided by total time. Okay, so since this one is speed, this one you have to use as distance, and this one is total time. So you can calculate total distance. If you guys still remember, if you have this graph, you find S ataupun distance, you can use area under the graph. Okay, so literally this is the area divided by time, half, multiply with the 10, the height is 10, and you can add this length, which is 120 minus 20, which is 100, and this one is 160. Okay, so 100 plus 160, and the time would be 160 seconds, the whole journey lah. So 260 times 10, you get 2,600 divided by 2, 1,300 divided by 160. Yeah, 8.13 meter per second. Because you are calculating the speed, so you don't have to bother with the direction. Okay, thank you.